Download this code from codegive.com, link in the description below. OK, let's dive into domain-driven design, DDD, tactical patterns. This will be a comprehensive guide covering various patterns with explanations and code examples in Python. What are tactical patterns in DDD? Tactical patterns are a set of design choices and implementation techniques you use to translate your strategic domain model, the big picture understanding of your business, into concrete code. They're the building blocks for structuring your domain layer. They focus on how to represent your domain within your software. Key tactical patterns. Here's a breakdown of essential DDD tactical patterns, along with their purpose, how to implement them, and Python code examples. 1. Entity. 2. Value object. 3. Aggregate. 4. Aggregate root. 5. Repository. 6. Domain service. 7. Domain event. 8. Factory. 1. Entity. Purpose represents a concept in the domain that has a unique identity over time. It's not just defined by its attributes but by who it is. This identity allows you to distinguish between different instances of the same entity, even if they have the same attribute values. Characteristics. Asterisk has a unique identifier, ID. Mutable. Its attributes can change over time while still being the same entity. Life cycle, an entity can be created, updated, and eventually deleted. Implementation. Product ID. Represents the unique ID of the product. Using a dedicated class for IDs is a good practice. Product. The entity itself. It has attributes, name, description, price, and an ID. Update _price, a method to modify the entity's state. Note the validation to ensure the new price is valid. Create, a static factory method, more on factories later, used to create the product entity, enforcing creation rules. Explanation. We use uuid.uuid to generate a unique ID for each product. UUIDs are a good choice because they are highly likely to be unique, even across different systems. The product SID is immutable. This is common for entity IDs. Once an entity is created, its ID should not change. The name, description, and price attributes are mutable. The update _price method demonstrates how you can change the entity's state. The static create method is a form of factory. It encapsulates the logic for creating a new product and enforcing certain rules, example the product name cannot be empty. 2. Value object. Purpose represents a concept in the domain that is defined by its attributes. Two value objects are considered equal if their attributes are equal. They have no identity of their own. Characteristics. No unique identifier. Immutable, typically. Once created, their attributes should not be changed. Equality is based on attribute values. Implementation. Address. Represents a postal address. It has attributes like street, city, state, and zip code. At data class, frozen equals true, makes the address class immutable. Explanation. There is no ID for the address object. It's purely defined by its attributes. The _eq__ method is automatically generated by data class, comparing the attributes of two address instances. Immutability is important for value objects. Once an address is created, its attributes should not be changed. If you need a different address, you create a new address object. 3. Aggregate. Purpose a cluster of associated objects that are treated as a single unit for data changes. It defines a boundary within which data consistency is enforced. Think of it as a transaction boundary within your domain model. Characteristics a cohesive group of related entities and value objects. One entity is designated as the aggregate root. All operations on the aggregate should go through the aggregate root. Example a customer aggregate might contain the customer entity, the root, a collection of address value objects, and a collection of order entities. 4. Aggregate root. Purpose the single entity within an aggregate that is responsible for controlling access to the aggregate's data and enforcing its business rules. It's the only entry point for interacting with the aggregate. Characteristics has a global identity. Controls all access to the aggregate's members. Guarantees the consistency of the aggregate. Repositories should only return aggregate roots. Implementation, extending the previous examples. Order item a value object representing a line item in the order. Order the aggregate root. It contains a list of order items and has methods to add, remove, and calculate the total of the order. It's responsible for ensuring the consistency of the order. Relationships the order aggregate root owns the order item value objects and the address value object. Access control the add item and remove item methods are the only ways to modify the item's collection. This prevents direct manipulation of the order item list from outside the order aggregate, ensuring data consistency. Explanation the order is the entry point for any operations related to an order. You don't directly manipulate order item objects outside of the order aggregate. The add item method enforces business rules, such as preventing adding items with a non-positive quantity. The calculate total method performs calculations based on the aggregate's data. 5. Repository. Purpose provides an abstraction over the data access layer. It acts as an in-memory collection of domain objects, allowing you to retrieve and persist entities without worrying about the underlying database or storage mechanism. Characteristics provides methods for adding, updating, deleting, and retrieving aggregates. Hides the data access implementation details from the domain layer. Returns aggregate roots, not individual entities within the aggregate. Implementation order repository an abstract base class defining the interface for order repositories. In-memory order repository a concrete implementation that stores orders in memory. This is suitable for testing or small-scale applications. In a real application, you would use a database-backed repository, example using SQL Alchemy, Django ORM, etc. Explanation the order repository interface defines the methods for interacting with orders. This allows you to swap out different repository implementations, example in memory, database-backed, without affecting the rest of your domain logic. The in-memory order repository stores orders in a dictionary. In a real-world application, this would be replaced with database interactions. The repository only deals with order aggregate roots. It doesn't expose or allow direct manipulation of order item objects. 6. Domain service. Asterisk purpose asterisk encapsulates complex business logic that doesn't naturally belong to a specific entity or value object. It often involves interactions between multiple entities or external systems. Asterisk characteristics asterisk. Asterisk stateless, doesn't hold any domain state. Asterisk orchestrates operations involving multiple domain objects. Asterisk performs complex calculations or validations. Asterisk implementation asterisk. Asterisk shipping service asterisk a domain service that calculates the shipping cost and communicates with shipping providers. Asterisk explanation asterisk. Asterisk the shipping service doesn't belong to any specific entity or value object. It represents a process that involves both the address and the order. Asterisk it's stateless. It doesn't store any information about shipping. It simply performs calculations based on the input data. Asterisk in a real-world application, the calculate_shipping_cost method might interact with external shipping APIs, example UPS, FedEx, to get accurate rates. 7. Domain event. Asterisk purpose asterisk represents a significant occurrence in the domain. It's a record of something that happened that other parts of the system may need to react to. Asterisk characteristics asterisk. Asterisk immutable, once an event is created, it cannot be changed. Asterisk represents a past occurrence. Asterisk typically contains the data relevant to the event. Asterisk implementation asterisk. Asterisk order created asterisk a domain event that is raised when an order is created. Asterisk order shipped asterisk a domain event that is raised when an order is shipped. Asterisk event bus asterisk the example shows a simplified event handler. In a real application, you would use a proper event bus implementation, example using a message queue like RabbitMQ or Kafka, or a library like RxPy. Asterisk explanation asterisk. Asterisk domain events capture important moments in the system's life cycle. Asterisk they are immutable, ensuring that the record of the event remains consistent. Asterisk the event bus, or message queue, allows different parts of the system to react to these events in a decoupled manner. For example, when an order-created event is raised, a separate service might send a confirmation email to the customer, update an inventory system, or generate a report. 8. Factory. Asterisk purpose asterisk encapsulates the complex logic of creating objects, especially aggregates. It helps to ensure that objects are created in a valid state and that the creation process is consistent. Asterisk characteristics asterisk. Asterisk hides the details of object creation. Asterisk can enforce invariance and business rules during creation. Asterisk reduces code duplication. Asterisk implementation, illustrating with order creation. Asterisk order factory asterisk a factory class responsible for creating order aggregates. Asterisk create_order, asterisk a method that takes the necessary data and constructs an order aggregate, ensuring that it's in a valid state. Asterisk explanation asterisk. Asterisk the order factory centralizes the logic for creating orders. This makes it easier to maintain and update the creation process. Asterisk the create_order method can enforce business rules during creation, such as validating that the customer ID is not empty and the shipping address is valid. Asterisk by using a factory, you can avoid duplicating the creation logic in multiple places in your code. Key considerations and best practices. Asterisk start simple asterisk don't try to implement all of these patterns at once. Start with the patterns that are most relevant to your domain and gradually introduce others as needed. Asterisk focus on the domain asterisk the most important thing is to understand your domain and model it accurately. The tactical patterns are just tools to help you do that. Ubiquitous language. Use the same language in your code that you use when talking to domain experts. This will make your code easier to understand and maintain. Testing. Write thorough unit tests for your domain objects to ensure that they behave as expected. Immutability. Favor immutability whenever possible, especially for value objects and domain events. This can help to reduce the risk of bugs and make your code easier to reason about. Error handling. Implement robust error handling to deal with invalid data or unexpected situations. Use exceptions to signal errors in the domain layer. Eventual consistency. When dealing with multiple aggregates, be aware of the possibility of eventual consistency. Use domain events and other techniques to ensure that your system remains consistent over time. Benefits of using DDD tactical patterns. Improved code structure. DDD helps you to organize your code around the domain, making it easier to understand and maintain. Reduced complexity. By breaking down your system into smaller, more manageable aggregates, DDD can help to reduce the overall complexity of your application. Better communication. DDD promotes better communication between developers and domain experts by using a ubiquitous language. Increased business value. By focusing on the domain, DDD can help you to deliver more business value to your customers. When not to use DDD. DDD is not always the right choice. For simple CRUD applications, the complexity of DDD may not be necessary. Consider the complexity of your domain and the size of your project before adopting DDD. If your domain is relatively simple and your application is small, a simpler architectural approach might be more appropriate. Conclusion. DDD tactical patterns are powerful tools for building complex, domain-driven applications. By understanding and applying these patterns, you can create software that is more aligned with your business needs, easier to maintain, and more valuable to your customers. Remember to start simple, focus on the domain, and use the patterns that are most relevant to your specific context. This guide should provide a solid foundation for understanding and implementing DDD tactical patterns in Python. Good luck.